All right, so I'm going to talk about benefits of continuous integration and using Travis CI specifically. So we're going to get into a couple topics, but first, you guys have gone through 4 other sessions today of like intense talk about why testing is important, and so I kind of found a couple, quotes from people in our community about testing specifically. I mean, untested code is broken code, and this is something I'd heard for years from these people when I'd go out to these various sessions, that if you don't have the coverage and you don't know the code's actually working, it's kind of like the Schrodinger's cat, whatever it is, it's in the box, you don't know if it's alive or dead. You can't assume that code is working if you haven't actually looked at it with a test in any way, shape, or form. And this wasn't limited to just the Zope and Plone community, but even the Django community. Code without tests is broken by design. You've planned for failure here without having tests ready to go. And even in the Linux kernel, untested code tends to be broken code. So with all this emphasis and importance on actually testing your code, we need to make sure that you do it often and so that it's easy. Because if it's not easy and you aren't doing it often, then it's just not going to happen. I think that's kind of an important bit here. We can talk all day long about using nose and PyTest and mocking and all these other kinds of things, but if they aren't actually being run in an active manner against your code, you're going to run into broken code at some point in time, where your code will break in some situations. So the quick overview of this talk is going to be like, what is continuous integration? Because I don't know if everyone here has heard about what continuous integration is or what it even means. How do we even get started with it? What are some of the prerequisites to enable us to be able to spin up into continuous integration quickly and be able to do these repeated testing over and over and over again? Some common build servers, so there's different technologies out there that will enable you to do continuous integration. And then whether you want to do it yourself or have a hosted service for this kind of thing. And then I'm going to specifically get into Travis CI, and you'll see why later, that it's a good solution, especially if you're doing open source projects. So in general, I mean, who here is using continuous integration right now? Okay, so we have a couple people in the room. I know we use it on a fairly limited basis, as it is anyway. So continuous integration was originally adopted as part of extreme programming. I kind of went back and had to read some of the history of extreme programming, and it's kind of scary that extreme programming came out of a lot of actually failed projects. So why we still use it, there's definitely debate about that, but I think that continuous integration as part of this is actually very important, because it advocates for merging of developer code as many times a day and as in an automated fashion as possible to run all the unit tests, so they're basically all checked frequently and often as you've got multiple developers working on one project. So you don't end up in this thing called merge hell. Who's been in merge hell before? Because basically, as the code diverges, as you're working on it and you're working on it and you're working on it and you're working on it, and everyone goes in to merge their code into the main line branch of the trunk, bam, like stuff happens. And then the idea behind continuous integration is to alleviate that stuff happening without you seeing it earlier in the process, and actually being able to track down those issues before they become bigger, more monstrous things to actually try and tackle. So things are basically, the more they're checked in small pieces of effort and applied frequently, allows testing before completing all the development. Or saying, if it's applied, small pieces of effort applied frequently is going to be the key to continuous integration. Without that, you end up with that getting all complete and doing the testing at the end and running into numerous problems that are going to be much harder to fix if you would have caught them earlier on in the process. Another benefit of, I think, continuous integration, and actually Randy kind of touched on this, it's not necessarily a benefit of continuous integration, it's a benefit of doing tests, is it's going to help produce more modular and less complex code on your side. It's going to be easier to understand your code because you've been testing it frequently. You've been splitting it up into easily testable compartmentalized pieces of code, so it's a lot easier for you to manage and actually write tests for it. Now, an important reason you may want to use continuous integration also is going to be if you have legacy projects, hopefully they had tests. If they did, it's much easier to confidently make changes to those projects as you go forward, knowing that you can run the test at any point in time and know you yourself haven't caused breakage in that project. Hopefully, if you're lucky, your legacy projects have some tests in them. So to get spun up to actually be able to do continuous integration, there's going to be some prerequisites that you're going to need to have on your side. I mean, the most important one here is probably, I don't know anyone who doesn't do this at this point in time, is version control that has atomic commits. And you need to be able to see the history of the code and also be able to spawn builds, like test builds of your code at each commit, and have them, basically a build can correspond to a commit inside your revision control system. That way you can easily point a failure directly back to a specific change. Without that, I think you would just be chasing your tail, and there's not much benefit to just running builds randomly. You need to be able to automate your builds, so it needs to be something that you can script repeatably. You can't just expect to run the builds, the test builds manually each time. First of all, it's going to be error prone, and second, people aren't going to want to do that. Just anything that has to be done manually will probably stop being done at some point in the future. They have to be self-testing and fast, so the faster your tests run, again, the more likely your developers are to run them locally before they even commit. But having them run fast on the servers, your build servers, is also important to the process to make sure that you get quick feedback to the whole process. If your build takes 10 hours to build, again, it's probably going to happen less often, and you're going to see less benefit from continuous integration. And optionally, you can actually have automated deployments happen. So some people do continuous deployment. I don't know if anyone's heard of that term, continuous deployment. So you can actually have your continuous integration system say, we're all good, deploy. And so basically commits from developers can directly spawn all the tests, which can then directly deploy onto your production environments if you want to be pretty extreme about things. So we've actually had presentations at IndiePy about certain continuous integration technologies. We've had one on BuildBot already. We personally use Jenkins in-house for our internal projects, and I'm actually going to show you what Jenkins looks like so you can kind of get a compare and contrast. And then I want to show off Travis. And then there's a bazillion of them. Everyone who ever wrote a web framework, some of them also wrote continuous integration frameworks as well. But there's other ones like Bamboo's, the Atlassian integration server. So some of them are commercial, some of them are open source, like Jenkins is open source. Travis is actually open source, and it's based on Ruby. It is a hosted service, and I'll get into that later in the slides, which is kind of nice because then you don't have to maintain a bunch of hardware, software, patches, etc. So let's take a look real quick at how Jenkins does builds. So as a developer, you will commit your code, and as you make that commit, you typically have hooks inside your revision control system that will ping the build server and tell it, hey, it's time to go do something. So as an example, I took the Python web framework shootout code that we did, the to-do app, and I actually put it into our Jenkins server. So you create basically a new project inside of Jenkins. You give it some descriptions like where is the source control repository, what kind of repository is it, and then how do I build it? And I'll show you that. So that's basically the settings for our repository. You can see at the bottom, there's the GitHub repository for it. But the most important part of setting up the project inside your continuous integration system is going to be the script section right here. Some of them are automatic depending on what frameworks and what projects you're using, like if you're using Maven or whatever. Some of these tools were pre-built to know how to build those projects. But in the case of Jenkins, it's a Java-based building server. So it just uses a little bit of shell script here. And what that does is going to, actually what it's doing right now is checking our code out. It makes sure that it's flake-ate, looks for errors like, grammatic errors inside the code, pulls in any dependencies that might be needed, and then actually initializes a testing database and then runs nose tests. So you can see the last command on the bottom there is just run nose tests. And then when that runs, you will get basically builds will happen. So as you commit code into your source control, it can kick off automatic builds inside of Jenkins in this case. And when you run a build, this one was actually successful. So it's got the big blue dot. It's got nice big blue and red. And actually, Jenkins gives you storm clouds and sunbursts and all kinds of fun stuff in Jenkins. But the key part is, if there was an error, you would actually be able to go to the console output of your build and see what the server did. I actually ran into an issue running this build against one of our FreeBSD Jenkins servers because the Python for FreeBSD does not, by default, include SQLite, where most other build systems would have. So there was a small difference in the environments, I had to make sure that our environments would match. So again, we host and run our own Jenkins server, which means we have to patch the OS, which means we have to upgrade Jenkins when there's new security patches, and all that stuff. We have to maintain the dependencies that would be built into the box if you wanted to be able to test with Phantom.js or use a Firefox headless. You would need to install and then, like I said, maintain and update and upgrade all these packages just so you can do your continuous integration. And kind of leads me back to, if it's not easy and if it's not fast, you're less likely to do it. So if this thing falls into disrepair, it probably hits the back burner as like a low priority thing to kind of maintain and keep up. So exactly, what if we don't want this kind of headache? We want to make sure that this just happens, it's all automatic, and we're all happy. So I don't know, who here's heard of Travis CI? So it's very similar to Jenkins, except for the fact that it doesn't have the headache. It's a fully hosted continuous integration service. If you're using GitHub, basically you have to use GitHub with Travis CI because it will look at the public repositories that are in your GitHub, and actually any of them can be turned on and built, and it can actually work against your private repositories, but then at that point you have to pay for their commercial service. Travis CI is open source, so you can go to their GitHub, clone their repositories, build your own Travis CI server, but then you're kind of back in the headache camp. But if you really like their system, you can submit patches and actually work on the project. So I really like the model that they're still maintaining an open source project. They do offer a nice value-added service, which is the fact that they host everything, they do all the build infrastructure, they maintain all the images and all the VMs and everything that goes on, and it's incredibly easy. It is super easy to use, and I'll show you that in a minute too. So basically what they do is every time you want to spin up a build, they've got Ubuntu 12.04 64-bit VMs with 3 gig of RAM and 2 CPU cores across multiple kinds of services. So they run on EC2, Rackspace, Heroku, where they've got basically, they're kind of agnostic on the back end. So your stuff may end up being built on 5 different platforms in one day, depending on what rates may be and availability of hosts and servers. So they manage all that back end stuff. You don't see any of this stuff. What's nice about their VMs is they have common tools. So as soon as they spin up a VM, it's a fully loaded Ubuntu with basically Git, compilers, curls, wget, OpenSSLs, ImageMagick, rsyncs, all these kinds of things you want to do. Phantom.js, there's a version of Firefox on there that they maintain and keep up to date all the time. So as the version dependencies change, and as there's updates and security releases and patches, you don't worry about that. You just know that the next build that comes out is going to be on a fully patched system that's ready to roll. So again, if it's this easy, we're going to have a much more likely chance of actually using this process. So how do you actually get started? As I mentioned, if you're running an open source project or you have a repository on GitHub that is public, Travis CI is free to use. Any repository where you are like a team member, I can't remember what GitHub's terminology is for it, you will have access to be able to build any of those repositories that are in any of those accounts. So when I log in, I see my IndiePy one, my 6-bit one, my personal one, and any project that I fork into my own GitHub account, I can also build. And when I build it, what's nice is if there's failures, it alerts only me, not the project author. But if I put a pull request in, this is another significant feature of Travis CI, is I can make a pull request for something I've patched in a project. That pull request can be built if the project maintainers got this set up that way, and they get notified that it's green or red or yellow, like whether it's safe to merge, going to have issues, or ready to go. So it saves other open source project maintainers time by allowing them to quickly see if a pull request is going to run the tests right out of the box. So I mean, kind of standard open source project etiquette is if you put a patch in, they're going to run tests against it to make sure it works. Well, this automates all that as well. So the quick and easy way of getting started is host your project in GitHub. Basically, you log into Travis CI with your GitHub credentials. You will see all of your repositories show up. You flip one switch, and you make sure one file is existing in your repository, and you are literally good to go. So let's show you guys the quick kind of walkthrough of that example. So in this case, I'm looking at the IndiePy to-do pyramid app that we did for the web framework shootout. And all I had to do at this point was log into you see the sign in with GitHub in the corner. So if you go to travisci.org, you'll get to this page. You can log in with your GitHub account. And once you log in, and you actually see all the public builds that are currently happening for all the open source projects that are currently using Travis CI, we'll just scroll up the side over there. I mean, they've been building hundreds of thousands of projects a day, which is pretty amazing, and all for free for open source, which is really awesome. So I logged in, I navigated to my IndiePy organization, and at the very bottom there you can see the IndiePy to-do pyramid app. I flipped that switch on. Basically it says this repository is now enabled and it will listen for GitHub commits. And if a Travis or .travis.yaml file exists in my repository, such as one of these, it will then build it. If it doesn't exist, it won't build it. So you don't have to worry about it like going off and randomly be building and spewing you errors because you don't have everything set up right. But basically this is a YAML file. The most simplest YAML file for Travis is going to be just to specifying the language. For Ruby, you can specify just language because they're kind of a native Ruby testing environment, but they support a bazillion languages. For Python, you do have to pass in the scripts key with what thing needs to run your tests. There are different stages in the build lifecycle, and so in this case, we want to make sure that to install our app into the server, it will clone our repository, and then it will run this pip install against our requirements file and getting in the additional extra packages for testing so we can have nose test and coverage. Next thing you do is push to your repository. As soon as you make a push, it is going to actually use a hook inside of GitHub to trigger a build over in Travis CI. You don't do anything else. So the first time I did this, obviously we had some failures. I think the test module was just the default scaffold test module from Pyramid. We hadn't changed anything. So it's kind of cool. I mean, right away I got instant feedback that the tests were failing. I had work to do, and I could make that thing green. So again, kind of motivation. It ran fast. It was quick and easy. I didn't have to do a lot of things. So let's actually make the test pass. So I put in a really, you can go into the GitHub repository for IndiePy and see this. So I put in a quick and easy, we created to-dos in that web framework shootout app. So I made a quick to-do test, just assert that I can make an item and I can set the user of the item and the task, and I can test that those things work. And lo and behold, test passing. What's kind of cool is it keeps the full build history, just like Jenkins does as well, but it's a lot nicer, cleaner UI. What was interesting was I did 3 edits. The first one was basically pushing the Travis YAML file. The second one, I made the tests work with one test in it. It never finished. Well, I should say it did finish. It took it an hour, and it still returned, and actually ended up passing. So I put a third request in because I was like, why is this not working? And that one built quickly and returned right away. So there is some lag sometimes depending on load and what's going on in their systems. But from what I've seen so far, even the one that I thought was going to, I kind of gave up on it, it still gave it its old college try and finished up and actually passed on me, which was kind of nice. So I mentioned that Travis CI is written in Ruby, but it supports other languages. So specifically, Python is well supported by Travis CI, but then you can see the list of all the other, there's a bazillion other languages that are supported by Travis. So you can run all your projects. Basically, if you can write those type of shell scripts we saw in Jenkins, you can pretty much write Travis CI to do those same kind of tests. Only thing limiting them is basically what they pack into that VM that they spin up on whatever provider they're using. Now, in addition to having the languages and the compilers sitting on the VMs ready to go, you also have hosted databases that are, some of them installed and actually enabled and ready for you to use. So you can actually write your tests and have them connect to a local database on the VM ready to go. For example, Postgres and MySQL, Mongo, and Couch, those guys are already on the server ready to roll. They've got special Travis CI passwordless accounts that you basically write your tests to use those databases. And you can actually specify other data, create new databases through your build lifecycle and set it up to work with your app, set up your schemas, do whatever you need to do, and then run your tests against real, full-blown databases as well. So you can do kind of more integration, end-to-end testing with Travis CI, which is nice. So I know we've talked a lot about mocking those kind of things, but sometimes you still need to integrate and make sure they all work together. So if you want to use them, you just add them into your YAML file and test. You can test against multiple databases simultaneously. So if your project supports MySQL, Postgres, and some other like SQLite, for example, and you want to make sure that no change breaks any 3 of those databases, you'll do what is called setting up a build matrix. And the build matrix can take in different database environments, different language versions, different versions of your libraries, and basically it builds out a giant matrix and builds for every one of those possible cases, and then sends you a build report after each of them, after each commit from all those cases. And I'll show you an example from a different project where they actually have a build matrix set up in there. So to use the databases, there's going to be inside the build lifecycle some hooks inside YAML. So you basically would specify a YAML key for before script to run like a database setup. Most databases are already started on boot, so it's again very, very fast because once these instances start up, Travis gets them running. As it runs through each of your unit tests, it actually uses the virtualization snapshotting to roll back the VM and run again, roll back the VM and run again. So it's actually very clean. Every run of your tests is clean as if it was done from the very beginning. So that kind of gets that cross-contamination issue that Randy talked about earlier. Travis can actually help you, suss out those issues and make sure your tests run clean. Some other database backends that aren't enabled by default but are installed are things like Memcache and Redis, Cassandra, some other things like that. There's a services key inside your YAML file. If you specify services : and give it a list of other potential services you would want, like Memcached or Redis, it will make sure those are started up and ready to go when your tests are starting to run. Again, you can use that same DB environment variable inside of your YAML file to make a matrix of builds across different technologies that you want to support simultaneously. So let's take a look at an example of the matrix build. So we've kind of seen the simple case. We had one language, one library, one test suite run against it. But if we actually wanted to run multiple tests across multiple languages, we do it like this. So in this case, this is actually going to set up a matrix across multiple operating systems, because Travis not only supports Linux, they actually have OS X builders, so you can do Objective-C, like iOS builds of code against their environment. So you can actually build other things against the OS X version as well. So you can actually cross-compile and do 2 sets of builds, one for Linux and one for OS X. And then that list of all the Python versions that are right there basically turns that into another aspect of your testing, where it's going to take Linux and run it against 2.6, 2.7, PyPy 3.3, 3.4, and PyPy 3. Then it's going to repeat and do the whole thing again for OS X. So you can see how you can get a scale of tests kicked off really, really quickly inside of Travis. And again, this is all free for an open source project, which is really, really handy. In this case, you can see they're going to call make for their script. There's also after success key hooks. So if you actually want to do certain actions after a success, in this case, run coveralls against your code base, you can actually have it pip install dependencies and go ahead and run another script after we've determined we've already had a successful build. So here's the results of the matrix build. So you can see where it's got the columns for like the Python version and the column for the OS, and then the build stats. I didn't wait for this one to finish building because it was taking a little longer because there's so many aspects to it. But yeah, it gives you a whole nice little grid showing you all the tests. Actually, in this case, the PyPy 3 one was failing, but all the other ones were successful. So then you can drill down just into that one build, see the console output, and see what was actually failing. And you actually get notifications about all these things too. So I talked a little bit about how their Python support works. They actually use virtual IMs on the Ubuntu VMs. They do not use the system Python for Ubuntu. It is going to be a package installed, separate Python that's completely clean and doesn't have any of the Ubuntu libraries already kind of pre-installed into it. These are all the various versions they support. Plus, they have support for PyPy and PyPy 3, or PyPy. I'm starting back up the Cheese Shop campaign, so there's no confusion between PyPy and PyPy. If you don't know what that all means, come see me later when we have a beer. But basically, the only thing you have to do is, in addition to providing the language, is the default one, actually, if you provide language, if you just say Python, is going to be 2.7. And then you have to specify all the other ones as a the list of Python versions if you wanted to run the other versions as well, or run a different version as well. And then you have to provide the script key to be able to run like nose test or PyTest or make or whatever your command is to kick off your actual tests. It uses pip to install third-party dependencies and packages. It includes PyTest, nose, and wheel are pre-installed into your virtual enums. So you don't need to include those bits as part of your setup script. So it simplifies the YAML file considerably because you don't have to necessarily do a lot of additional work to get things ready to install. Most of the things you need for a build are already on there. So I kind of talked about it earlier, but there is a build lifecycle. So inside of your YAML file, I've already shown you like language, and then you set up the script, but you can also set up the before install, before scripts, after success and after failure, and after scripts. Before install would be setting up dependencies that would be needed by your build of your app. So if you had additional system packages in Ubuntu you needed, maybe certain C libraries needed to be installed for you to be able to build your Python lib, you would do those in before install. Before script would be things like setting up the databases. So if you had database schemas you needed to be able to run or install against the system. And then actual run is going to be in the script part. After success and after failure apparently are going to change, so don't depend on what they currently do right now. And then the after script, which is I showed you earlier, where you could run something like coveralls or other coverage tools against your build and get separate reporting on that is also available. In addition, I didn't put it up here, but they do have the build success like auto deployment features built in. So Travis CI has the ability to auto deploy to various environments that are kind of supported by their system, which is like Heroku, Engine Yard. There's a pretty good list of ones that are supported. But you could run continuous deployment as kind of an add-on to doing the standard Travis CI builds. So there's some tips you may want to keep in mind if you're using Travis CI. If your build takes a long time to run, you may want to consider using the matrices to split up your build into smaller chunks. Because there is a time limit from Travis for like open source projects. I think it may be 15 minutes. If your build takes longer than 15 minutes, it's going to just cancel it and go along. So you may want to do things to speed up your build if it takes longer than that time limit. So splitting it in using matrices to test one half versus another half, you can actually cut your build time in half. You can actually run your full build again still against Travis. You can pull in dependency caches. So if you had, for example, Plone, if you guys know much about Plone, it has a bazillion eggs that are part of its build. I mean, we're talking hundreds. Pulling all those eggs in takes time because you need to pip install this, pip install that. I mean, it's just lots of transactions. You could actually feed it a cache file, like a zip file that already had all those eggs bundled up in it. One download, extract it, and now you've got 100 eggs installed and ready to go. And then Travis will maintain that cache between runs, so it doesn't have to go grab that whole cache again, because you can actually specify it specifically in your YAML file that these are supposed to be cached. If you have sensitive data in your build, so like database passwords or certain things you just couldn't get out of the build but are required to build your application, you can still have those in your build, but you can encrypt them using Travis CI's public key. So this is really handy because you can actually allow Travis to decrypt it as long as you've got it encrypted with their public key and then no one else can see it. Again, I don't think it's a good idea to put sensitive data in your open source or your open GitHub repositories, but if you had to, Travis does have a way around it to make sure that certain sensitive data doesn't get exposed. They actually support encrypting source code files as well and decrypting the source code files before you build. So they can do some pretty tricky things when it comes to making sure certain sensitive data or your secret sauce stays secret to the world. The build status images I already showed you, so it's like that build failed or build success. You can actually embed those into your GitHub readmes, the readme files. So someone else had mentioned earlier that GitHub will render your readme file right onto the front page of your project. Well, if you put in the link to the image is dynamic and it'll change based on the status of the build. So you've probably seen some GitHub projects where if you go to their page, it says like build's currently passing or build's currently failing. That's supported under the Travis stuff. And I mentioned already that pull requests can kick off builds of their changes. So as a project maintainer, you probably want to enable this kind of feature so you don't have to go and run the builds yourself before someone, or when someone commits code to your project. They can have actually Travis CI just automatically do it for you, which is really nice. And then if you had small commits that you actually didn't want to kick off a build, there is you can use this in square brackets CI skip in the commit message. And it'll just skip over that build and actually won't go ahead and build this time. So there are ways you can actually tell Travis, don't worry about this one, I don't need, or I know something's going to happen bad, and don't worry about building this one. We're all good. Now, key things that I think I mentioned before, but Travis CI doesn't maintain any state between any kind of builds. So it's very clean environments each time you do a full build, and the next time you come around, it's a completely full, clean build again. So with all this great fun buildness, we want to make sure that developers know they've done something wrong or right. So Travis CI actually has a full suite of notification tools built into it. The default for GitHub is going to be notify the maintainer, and notify the author of the build status. So if I pushed code into the IndiePy repository, whoever were the author, did you get an email from the Travis system? Maybe it didn't associate your email address with the code. But you would notify the author of the code as well on changes to the state build. It supports IRC, HipChat, Slack, webhooks. So I think who was talking about having the flashing red light in the office? You could do that with Travis because you can basically have it hit a webhook someplace that talked to an Arduino and turned on a light. It's pretty trivial to do that kind of stuff with Travis, which is nice. You can customize all these notification methods, and you can also customize the data that goes into the notification. So whether it's a text or a chat or an email, those templates can be modified in your Travis YAML file that you put into your repository. So you have full configuration control of that. The webhooks post JSON to whatever endpoint you feed it, and it has tons of info about whatever just happened. So all the metadata about your project, all the metadata about that build, and everything that happened is basically contained in that webhook post. So you got a lot of flexibility about what you can do there, which is nice. So what do they look like? So when I did that first push for the To-Do Pyramid app, in my inbox landed a nice email from what looks like Bob the Builder, but it's actually Travis CI, and said the build failed. And upon success, I got a nice, fancy, rich text email saying the build was successful. This is too easy not to use. You all should be doing this. I mean, whether you're doing with Travis or whether you're doing with Jenkins, I mean, even Jenkins isn't that hard to maintain. Doing continuous integration is really not that hard to do. There's actually hosted Jenkins services out there as well. So you don't have to use Travis. There's people who've taken Jenkins, made it into a software as a service platform, and will host that for you as well. With full support for GitHub hooks and Subversion hooks, and anything you could do to ping that server will basically kick off a build to pull down your code, which is really nice. So if there's any questions, I'm happy to talk about continuous integration or anything else anyone's interested in.